The idea behind this app is to track the growth of seedlings, so to help home gardeners try to manage growing their vegetables from seeds. I'm one of those people, and so here I am. And what we're going to do is just show you how it works. I've switched the camera to the other side. The idea is to take a picture. So one option here is this reference point. So it will allow you to size things. Let me show you how that works. Clear the photo. And what I've done is put a quarter, a US quarter in here. And what I'm going to do is actually here, you can save the calibration, but I'm going to uncheck that for now. So I'm going to say it's a US quarter. So these are some options for figuring out the size of things. And then I've put a quarter in the picture. I'm going to take the photo. And this is a bit tricky, but what it does is it will show the quarter in my picture, and I've got to change my X position. So what I want to do is to measure the diameter. So I want to put the points at the edge. And this is to calibrate it so we can say, how many pixels equals how many centimeters so that we get true measurements. All right, so that's about right. And what I can do then is say, okay, that's the distance. And then look what it's done. It's now figured out the length of my leaves. Now, this lower one here is a little off because it's included 3 of them, but in general, it's picking up the length of my leaves based upon the object detection. Then it tells me it's found 14 plants. The average leaf length is 1.22 centimeters, ready for first transplant to individual pots. And then I have some data for length over time. And these, because I think I've been testing with different images, are not accurate. And this is how many plants it's finding. And in fact, these are interesting growth data. Let's see if this is... So it actually looks like it's saving the measurements way too many times, like multiple times a second. I think that's a Streamlit issue that we're going to have to take care of, so we will debug that later. But that will give you an idea of how this works. So my idea is to be able to use this OpenCV library in order to detect growth of my plants, and then from that determine when it's the right time for me to transplant them up. So normally what you do is start them as seedlings. Once they germinate, you can start measuring the lengths of the leaves. When they get to a certain size, you should then move them up into bigger pots, and then eventually you'll plant them outside when they're ready to transplant. This is the final iteration of this. Like I said, this is saving it a little bit too often for my liking, so we'll do a little debugging in the midst, but this is how it works. I will show you the process for me to create this app. I started by coding this in the Streamlit online app, so share.streamlit.io. You connect your GitHub account to it, so this is my GitHub account, Technovation Curriculum, so you log in. It will ask you to connect your GitHub, and I highly recommend doing that, and that way you'll be saving any coding that you do in a GitHub repository. So I started it. Mine is called the Seedling Analysis Streamlit app. Starting from scratch, you can just start with my new app. So what I can do here is say right-click and edit with code spaces, which I've done, and it will open it here. For this, I used several generative AI tools. My main tool was Claude. Claude I find very good for coding assistance. However, at different points, I did switch over to ChatGPT. I was having some issues with Claude kind of giving me the same answers over again that were incorrect, so I switched over to ChatGPT for a while. In addition, at some points I was coding in Visual Studio Code, which has the option of allowing you to get some help from GitHub Copilot. So I did at some point ask it to give me some help, but mostly I used Claude. At some point I did use Gemini for a bit, but My main helper was Claude, I would say. Here's my first iteration, and I will open this in the browser. So this will show you what my initial app looked like with the help of Claude. So it was allowing me to choose different plant types. In the end, I'm just going to focus on peppers. That was the plant I have seedlings of my own to test with. In this first iteration to calibrate, I had to put in my estimation of the container width and scale adjustment. So this is a first iteration. We changed it later to use those points that I showed you to calibrate it better. And then these were different things we could choose in terms of manipulating the photo. So let me just take a photo. This, let's say. So it was able to find this 2 plants, and you can see there are some other smaller ones in this, so you could play with these sensitivities. Yeah, so down here would tell you how many plants found, the largest height. So at this point I was also looking in terms of height. In the end I switched it to look from above rather than from the side. This seemed too difficult, and I was able to get better clarity from above. So yeah, so this gave me some manipulation with it, and this was all supplied by Claude. Some information about what was happening. So this led me to, I need to learn a little bit more about OpenCV. So OpenCV is CV2 is the import, but OpenCV is the main library, which is open source computer vision library. So a lot of really good stuff in there. I felt I needed to learn a little bit more about that. So I went back and said, let's do like a test app where I can learn a little bit more about the different parameters for object detection. So the ability to, in this case, I was going to really just look for the green, right? The green in the leaves of my plants in order to detect them as objects and then measure them. That was my next step. Let's go here. And I'll stop that one. And now I'll do Streamlit run test app, this one, to show you what this one looked like. And, it even named it nicely to me, OpenCV Plant Detection Parameter Playground. So let me, again, use the same picture. So this gave me a lot more over here in terms of what I could potentially play with in terms of manipulating some parameters. So the main things I think I looked at were the color detection, so hue, saturation, and value. So it is finding a few more. Saturation mask. Now it's finding some of the green in the soil there, which we don't want. This tells you what the mask is and what it's finding. Now it's starting to find these different areas. This was all built by Claude for me, so I found this really, really helpful. So removing some noise here, which would clean up some of the dirt. And then the size, so how big can a plant get within the picture, and we don't really want much more. So it did pick up this bigger plant. Shape filtering, width, height, minimum, and this was really to detect stems, because at some point I was only getting the leaves. And in fact, at some point I switched over to my overhead, so none of this wasn't really necessary. This might allow me to find, a few more four plants. And it's even finding, I think, things that are not actual plants here. So I played around with this. It gives you a lot of nice information. It was giving me information in pixels squared, so initially I was okay with this, but I definitely wanted things in terms of an actual measurement of leaves. It then printed out what the parameters were, which is really, really helpful, right? So this was code that I could then copy and paste into my final version. So once I felt I had something that was working well, I then actually switched over to locally on my machine. Started to use Visual Studio Code because I thought I could play it a little bit more locally, and then I'll move everything up to share.streamlit.io. This is when I switched over to ChatGPT. I've been working quite a lot with Claude and getting help from Claude, but it was at one point it was just not giving me the results that I wanted, and it was repeating instructions to me that weren't working. So I said, let me give ChatGPT a shot here. And so ChatGPT gave me a much more simplified version of this. Let me show you what this looks like. This one's not a Streamlit, so I went back and asked ChatGPT, and it gave me a Python version. So let's go to ChatGPT, v1.py. Okay, and what this does is it gives me my green mask. And this one is where I first shifted to looking down on the image. So it's picking up all these, some of these are indeed images, but some of it's just little green bits in the soil. So if I hit escape, and then it will tell me what it's found, which was pretty good, pretty good. In fact, yeah, these were the beginnings of, yep, these were. So I thought it was pretty good. It missed a couple, like it missed this one here, but generally I was pretty happy with this. And this was after me playing with the values in the code quite a bit in order to be able to pick it up. And I was working with mainly this image, so I had a couple of seedling samples. I then used this simplified Python code. I then said, okay, let's go to Streamlit and turn this into a Streamlit. Initially, I was working with ChatGPT, but then halfway through, I shifted back over to Claude to help me with it. My initial idea was, that someone would use this as an app on their phone. They'd go take a picture and then have it analyze it for them. Not necessarily uploading pictures, which I suppose you could do. So I took photos myself and uploaded them for testing. But now at this point, I'm shifting over to the phone. Now running this and getting it to show up in a phone was a tricky process. So when you normally run a Streamlit app, it does Streamlit run and you give it the name of the Python file. So this is my file, ChatGPT Streamlit.py. Then I wanted it to show up on my phone. So in order to do that, I had to add this code minus server port. And normally it runs it on port 8501. It was giving me trouble, so ChatGPT suggested I move up to 8502 as a port. And then if I run it, so because it's showing up on my computer, I actually want this to run on a phone. So what I had to do here is go down to my ports, and you'd have to say forward a port, and I would say 8502. And this is the way it works. First I have to say, instead of private, I'm going to make it public. So I'd right click on visibility, and I would say make it public. And then it would say, be careful about this. So I'd say, okay, continue. And this is the address. So what I would then have to do is take this address, which is a URL, and I would copy it, and then I would send it to myself in like a text or an email. So from my computer, I would then take that, and in my phone, so here on my phone, I would open this up, and then it tells me to be aware that I'm about to use this dev tunnels. So use it only if you trust the person, which is myself, so I do trust myself. And then this allowed it to use my camera. There I am again. I can switch the camera to my other camera and then, take a picture here. So I am able to actually run it. So let me just kind of go through how the app works. Up here are all of the different libraries. So the important ones here are, the normal Python libraries that we use, Streamlit, NumPy, Pandas. OS is allowing us to store and save files, date, time. This drawable canvas is what's going to allow us to do that calibration with the quarter. So allows you to specify 2 points on a picture. So the calibration CSV is where I'm storing that calibration data. So my idea was, once I've set up calibrating the quarter, I'm probably going to go back and take the same picture over and over again of the same seedlings. So I don't want to have to do that every single time because it was kind of painful. Here's my timestamps for when I've done it. And this is the one that I really want, the US quarter. So it's 0.04. That's a good thing for me to know too as well, right? That stores the data. And so the idea is here in my load calibration function, if this file exists, I would read that in and store that as my centimeters per pixel. So grab that out of that spreadsheet and store that information. This save calibration is if I'm actually doing the thing with the points, where I'm calibrating the points on my image with the red and the blue lines, then I would use that and store it. And going back here, this use save calibration will automatically try to pull it out of the spreadsheet. If I don't do that, that's where I've got my points and everything. So I want to use that because I've already gone through the process with my quarter. So this function just stores that information in the spreadsheet. Once I've used the point system to calibrate it, I will save that information and then it will pull it from that document. This just sets up the title, the header, and all that. Then I've got a second CSV, which is the data CSV, which is the growth data. And this one has 3 different columns: timestamp, the average leaf length in centimeters, and the plant count. So how big everything is and the number of plants. So this will open it. This takes a picture from my camera. All of this is the calibration part. It tries to load the calibration, and then it will set this skip calibration true or false depending upon whether or not I've got that checkbox. And if we're not skipping it, it's going to go through the whole process of allowing me to set those points. Here is where we start to deal with the image. If image data is not none, is basically determining whether or not we've taken a picture. And if we've taken a picture, image data will have something in it. The next step is to convert it. So image.open opens the image as a Python image, which is in RGB format. We want to convert that image to OpenCV format. So what this does is converts it into a format that is accessible by OpenCV. So OpenCV uses BGR. RGB takes an image and gives us the information in 3 channels: red, green, and blue. It's 3 values. Each value has a range of 0 to 255, and it will tell you the value of each pixel in the image with a red channel, a green channel, and a blue channel, RGB. Now, OpenCV looks at it by swapping the blue and the red channels. And this is just historical. When OpenCV was first developed back in the, I think, 1980s, the standard was BGR. And since then, for the web, we flipped it in its RGB, but they've kept this historical standard, converting it from RGB to BGR and then putting it into an array. And now the OpenCV libraries can deal with it. All of this is just to have it fit on my phone, because the intention of this Streamlit app is to run on a phone. The original image was not fitting on the phone. It was just extending past the screen width. This is just to scale it so it fits on a phone screen. This whole section here is if we're not skipping the calibration. So remember, we have the option of our historical calibration that we stored in the spreadsheet, and we can skip it. If not, we have to do the whole thing with choosing reference points and then restoring it. Otherwise, we will get the centimeters per pixel from the spreadsheet. Okay, and here's where we start to discover whether or not we've got some leaves in our picture. We are converting, we talked above about BGR, so blue, green, red channel, and we're going to convert now to HSV, which stands for hue, saturation, and value. Instead of the 3 channels, we have kind of 3 characteristics. Hue is the color, and that is a degree in a color wheel. So instead of just, reds, greens, and blues, we're now talking about a color on a color wheel, and that ranges from 0 to 360 degrees. The saturation is a percentage from 0 to 100. Obviously, the more saturated something is, kind of the color is more vibrant. And then the third thing is the value, is the brightness of the color. That also is a percentage, 0 to 100%. Okay, so we're turning it into that value, hue, saturation, and value. And then this whole thing is allowing us to determine if we see green pixels in the image. So remember that we're looking at a picture of plants in soil, so we get kind of a brown background. And so what these do are give us the kind of range of the lower green range and the upper green range of what we are looking for in the image. And the mask creates a mask of the pixels that fall within this range. So what we get here is our mask, which is converted to just the black and white, where the white will be the greens or the leaves in our image, and the black will be everything else. So this is where we're discovering the objects, or in our case, the leaves in our plants. Once you do this, then we do this morphological cleanup. It basically cleans it up by filling in any kind of blank spots. The kernel is saying make a 3x3 array or a 3x3 pixel area and basically clean it up. So say we have a white leaf and it's got some little black dots in it, and that's just going to fill in those black dots with white. Likewise with the black background, if we get some little sprinkles of white dots in there, it will clean it up. So basically the idea behind this is to clean up by opening and closing areas of the mask so it fills in and also opens up areas that need to be opened up. Fine contours found to the edges. So once we've created our mask, we've got our image with the kind of blobs that are our leaves, and then this discovers the edges. So basically like outlining the edges of our blobs. This is initializing an array from the leaf lengths and the count of plants. We will now loop through the number of contours we have, which is going to be the number of plants. We get the area, and we're saying the area has to be greater than 30. So if the area is greater than 30, we're going to assume it is a plant. This is going to give us the bounding rectangle, so we can draw a box around the entire plant. We're assuming kind of a standard squarish shape, so we don't want the aspect ratio to be too off. We get the diagonal, and then we convert to centimeters and divide by 2. So this is our leaf length estimate here. And then we write the lengths of the leaves here. We say, okay, we've discovered a plant, we add 1 to it. We draw the bounding box around it, so it draws a rectangle, and then a line, which is the diagonal. And it also will add some text there to give the length of the leaf. And then once we've looped through all of this, it will give us the average leaf length. Simple average calculation. And then this is all added to our data frame, which we're going to add to our spreadsheet. This line here is just displaying the actual image. These lines are displaying the information about the number of plants detected and the average leaf length. This whole elif construct here is to display appropriate messages to the user depending upon the average leaf size that is found. Whether it's like it's not ready to move up to a new pot, or ready to go outside. This whole if is to say whether or not we want to save the measurement to our growth data, which is here. So the date and the average leaf length and the count. And then this whole plotting section will take the data from the growth data spreadsheet and display it in the graph nicely. We did find a couple of issues with the growth data as well as the calibration data. So let's take a look at that and see if we can figure it out. This is one issue, is that it's saving it so many times and I don't really want it saved. And I believe the same with the calibration data. Yeah, look at that. So let's do a little debugging right here, right now. I'm getting some help from Claude, and I asked Claude, let me just show you my conversation here. So it's saving my growth data and calibration data multiple times. Can I control that? Yes. It's happening because Streamlit reruns the entire script every time you interact with any widget. Here are solutions. So use session state, add a manual save button. I kind of like the manual save button. So I think I'm going to try to implement that. So let's I also have asked Claude to not rewrite. Very often Claude and also ChatGPT does it, where they will give you the entire rewritten set of code. And I don't like doing that because I like to learn as I go. I'm gonna kind of follow its directions and see if I can fix this issue. So, all right, so really it's just putting in after I've got my average leaf length and plant count. Yeah, which is really here. We're gonna insert this. All right, so let's save that. Let's see if that works now. 18 plants, wow. And now we'll say, let's save this measurement. Ref options not defined. And what I'm going to do here is put an if st button. So put the saving of the calibration data also under a button so it doesn't happen every time. All right, and we don't need this here because it doesn't know about it. We got an error. So let's try saving that. Let me go back. And we will recalibrate again. So let's go back to here. I'm going to put in my US quarter. Let's take my picture again. All right, I think this looks good. So I'm going to say save this calibration. Okay, now I'm going to say I've got these 12 plants, and I will then say save this measurement. Okay, and notice that all of my growth is messed up, so I can go back over here and I can really eliminate a lot of it. I'm going to take everything from today. So look at all these, crazy. Delete all those. So I've got my 2 entries there, and then I'm going to save that, and I will go back to my calibration data, which also, I don't need all these extra ones here. Save that. Okay, now let me go one more time back here, and I'm going to rerun it, and I'm going to use the saved calibration. Show you what that looks like. So let me rerun. All right, so I'm going to use the save calibration. That's fine. And let's go to switch my camera, take my picture. It's going to show me my growth. So now that I've got just those 2 points, Interesting. Let me make sure it's not saving at 2 places. So this actually is duplicating our efforts down here, right? So let me do that again. Let me fix our data. So I don't need that one. So I should have 2 entries, yesterday and today. Let's go one more time, rerun it. So I'm going to use my saved calibration again. I'm going to switch to the other side, take my photo, and I can then save this measurement, which should then, Yeah, so it read it slightly differently between previous one and this one. But now I know I've got the 3 entries here. So there we have it. We have an example of how you can use OpenCV, the OpenCV library, in order to make an app that will identify objects. In this case, I'm identifying plants, and I'm using it to help myself as a home gardener to decide when it's time for me to transplant my plants. And there's several stages, and this will assist. So this is an example. You'd obviously take it to a much more complex level. I'd probably include what Claude was originally suggesting, which was including different types of plants. I decided to just use peppers as my simple example because that's what I'm dealing with and that's what I'm planting right now in my garden. So lots that you can do with this, but this should hopefully give you an idea of what the possibilities are. I do recommend that you learn a little bit about OpenCV first. Here is their website, opencv.org, and they have all sorts of information getting started. I actually did a bit of this OpenCV bootcamp, and it will help you learn quite a bit about computer vision and how you can use OpenCV. It's all free. It's a really good course, and I think it's a great idea to learn a little bit more about computer vision before you start building your app. Good luck.